What is blockchain? How can IoT benefit from blockchain? What are some examples of IoT using blockchain? And why does the average maker care? Stay tuned for the answers to these questions. If you've clicked on this video, then you're probably aware of either IoT or blockchain. Both have been marked as disruptive technologies, and for good reason, but more on that later. At any stage, you can skip ahead by clicking on the right of the screen, or you can skip backwards by clicking on the left. Now let's take a look at blockchain. By now, everyone should be at least slightly aware of Bitcoin. This is a financial transaction model built upon blockchain technology. It is the first true cash-like technology for the internet. To be able to understand what blockchain does, let's first take a look at a cash-like transaction.
Here's a typical game of Monopoly. Okay, it's a German Monopoly set, so I'll have to provide subtitles for you. You know the type of game where one person has all the assets and everyone else spends the last half of the game just paying out. Here's Heinrich.
Grüß Gott. Klaus, möchtest du etwas trinken? Nein, danke.
And here's Klaus.
Hello.
Klaus will shortly be owing Heinrich a substantial amount of money.
2, 3, 4, 5. Oh, das ist schade.
Which is around 4,000 Deutschmarks. He looks in his wallet
Ich mag dieses Spiel nicht.
and discovers he has enough. So Klaus gets his money and verifies its integrity,
1,
and then proceeds to pay Heinrich.
3.
Heinrich, being the shrewd businessman he is, wants to check the money.
Lassen Sie mich überprüfen nur das Geld.
He knows it's legal tender because it has all the hallmarks.
Ja, alles ist in Ordnung.
This is a typical cash transaction. It happens many times a day. No, actually, not quite like that really. But anyway, up until Bitcoin came around, there was no equivalent cash transaction for the internet. Blockchain has 4 key aspects to its technology. It's distributed, it's transparent, it's persistent, and it's secure.
Bitcoin is a distributed network of many computers called miners that at the very simple level validate, sign, and approve transactions. The miner who gets to do this for a particular transaction will be elected by random lottery. This lottery is calculated by all miners consistently generating random numbers, and a new miner will win usually within every 10 minutes. All details of every transaction is recorded with full visibility to everyone on the blockchain network. Even though you cannot connect an account to a person, every transaction on every account is up there for all to see. Every transaction is added to a blockchain, providing historic transaction data. Every new transaction is cryptographically signed by the person sending money, and will also be cryptographically signed and approved by miners. No central authority is required, since everything is transparent. A transaction can and will be verified by all miners on the network. Not only that, but the latest block will contain a fingerprint hash of the previous block. Therefore, transactions only get more secure the more blocks are added.
There are several advantages to blockchain. Removal of a central approving authority effectively lowers the cost of a single transaction and opens up the opportunity for micropayments. A blockchain is designed to run on a completely untrusted network. It can run on anonymous computers, even malicious computers with dishonest owners. Blockchain makes it practically impossible to modify a historic transaction. The more miners that exist on a blockchain network, the harder it is for data to be altered. New transactions can be validated within a very short time frame. Often banks can take up to a week to approve transactions. New transactions can also be confirmed with a good amount of certainty whether it can actually take place or not. Duplicate transactions can never occur because only one miner gets to approve the transaction on the blockchain network. So this sounds all fantastic. There has to be a catch. Well, there is. Some critics have pointed out that as more and more blocks are added to a blockchain, it will require more and more computing power. This will make it prohibitively expensive for the casual miner to enter the blockchain network. For example, one of the biggest miners, Bitfury, secured $20 million last year to build a 100 megawatt center in the US. The number of miners that exist on a network is proportional to how secure the network is. So as less and less miners enter the network, this will increase the risk of data being modified. That is, the cost and effort required to modify data on thousands of computers is very high and beyond the scope of anyone. However, doing the same on, say, 12 computers is fairly achievable.
Now let's look at the Monopoly game again from a Bitcoin perspective. You know the type of game where one person has all the assets and everyone else spends the last half of the game just paying out. Here's Heinrich.
Grüß Gott. Klaus, möchtest du etwas trinken?
Nein, danke.
And here's Klaus.
Hello.
Klaus will shortly be owing Heinrich a substantial amount of money.
2, 3, 4, 5. Oh, das ist schade.
Which is around 4,000 Deutschmarks. He looks in his wallet
Ich mag dieses Spiel nicht.
and discovers he has enough. He knows this because 1,000 independent computers on the Bitcoin network have all agreed that this money was given to him from a previous transaction, and then proceeds to pay Heinrich. So Klaus adds another block to this transaction chain by cryptographically signing the transaction details. This transaction then enters the Bitcoin network, where it is cryptographically signed by one of the lottery-elected miners and approved by all miners on the network, and ends up in Heinrich's Bitcoin wallet. Heinrich, being the shrewd businessman he is, wants to check the money.
Lassen Sie mich überprüfen nur das Geld. Ja, alles ist in Ordnung.
Now there's one last thing to cover with blockchain, and this is where it gets really interesting. Ethereum is an addition to blockchain that allows the execution of arbitrary code based on any condition you want to apply within the Ethereum blockchain network. Ethereum isn't a marketplace, but a distributed virtual machine for executing code called smart contracts. Like Bitcoin, it has its own currency and is used to pay miners and executors within the blockchain network. A user can come along and create a smart contract written in a language of their choice, which gets compiled into EVM bytecode. Once uploaded into the Ethereum network, it can be executed based on the conditions set within that smart contract. Execution will cost the user, and the longer it runs, the more it will cost. This creates an atmosphere of one-shot, quick execution of EVM bytecode. Ethereum provides these capabilities: an unaltered transactional database, historic logging, secure transactions, microcomputations, and micropayments. In short, blockchain has been disruptive to the financial market. Ethereum is rewriting the IoT architecture. Smart contracts give the IoT device the ability to pay for the detergent and notify the customer when delivery occurs. Where did this come from? Your fridge can tell you how much milk you have left and automatically add it to your shopping list when you run low. Who drank all the milk? When you buy a vehicle, it'll keep a complete record of what was replaced, when, where, and who replaced it. This looks good. I'll take it. When your car has a fault, it will alert your mechanic automatically and book a free time in his calendar for repairs. Sell your fitness data in real time to the highest bidder. Why not set up your own IoT-based rental car company based on the Ethereum blockchain network? Hopefully you'll be able to see by now just how important blockchain is for IoT. IoT has earned security concerns from critics, and the cost to implement IoT architecture is prohibitive for individuals. However, it's fairly trivial for an IoT device to enter the blockchain Ethereum network. Once connected to that network, the IoT device can issue smart contracts or be operated on by smart contracts. The cost of entering an Ethereum network is a fraction of the cost of building an IoT architecture. Essentially, blockchain ticks all the boxes for IoT, and especially for the individual maker. This opens up massive free market opportunities and allows small players such as Joe Next Door to create products he can actually sell. So as you can see, blockchain holds a lot of promise for IoT and the average maker. But can blockchain address the critics' issues? Time will only tell. Thanks for watching this brief overview of blockchain and IoT. In a follow-up video, I'll be taking a look at blockchain's competitor called Tangle. Let's see if that opens up some more opportunities. Until then, see you next time.